Hello, hello. Wait. Okay, very good. You do already. Okay, this topic today that we are starting is solving quadratic equations in one variable by graphical method. Very long, got a lot of new words inside, but never mind. Let us go to the graph that I give you. So all should be looking at the paper that I give you. Okay? Like all your graphs, we always start with an equation. Do you all still remember what does this equation tell us? No. What is this equation actually telling us? Wrong. There are two solutions, also wrong. When we started with the plotting of graph, whether it is a straight line, whether it is a quadratic, become a curve. No. This equation actually tells us the relationship between y and x. Okay? And I told you, y equation we call it a function. Then your x become a number that keeps changing, and I call it start with I1. Wrong. Well, you all just try all the words. I call x the input, and what did I call y? Output. Because when I change different x, my y will change also because of this relationship. Okay? So this equation is the relationship between the values of x and the y. And normally, when you have a table, your first row is your x, your second row is your y. You put a different x, a different y will come out. Okay? And then when we plot the points, so for example here, this point here means that when my x is 1, the y is 6. Okay? Then, when I join all my points together, actually, not just these points are the solution or the relationship. Every point on this line that I draw, it will satisfy this equation, or it will fulfill this relationship. Okay? Get it so far? Okay, this is what you all should have already know. Then now, let us go to today's new thing. Are you all able to solve this equation without looking at the graph? Are you all able to solve this equation? This is a quadratic equation. Luis, chapter 2, we learned how many ways to solve quadratic equation? 3. The first one is factorization. If I can factorize this left-hand side, I can solve. Then I can complete the square, or completing the square will lead to quadratic formula. Okay? Quadratic formula will be able to solve. So if I want to solve with quadratic formula, I must go and write down First I must list down my A, B, C, right? So my A is -1, my B is 2, my C is 5. Then after that, I go and put my quadratic formula, substitute, then I can find, correct? Okay, so today we are learning another new way to solve this quadratic equation. So now I want you to notice this left-hand side, -x squared plus 2x plus 5 is exactly this right hand side, -x squared plus 2x plus 5. Okay? So when my equation of my graph is also the equation of is part of the equation that I want to solve, actually I can use my graph to straight away tell you the solution. Solution means I am finding the x. So instead of going through all this calculation, when I see here, like magic like that, I can tell you the solution is negative 1.6 and the solution is positive 3.4 for this equation. Okay? Can? So, y. Now we go to the y. This equation that we have. Sorry, my finger a bit wet. Okay, this equation that I want to solve, here and here, you see this left hand side is actually my right hand side. Then if this right hand side is equals to 0, can you see that if I extend this relationship that I have, it will become I write another equals. Usually we don't write that. This is just to show you. So now, I want to solve this equation. When I overlap them, can you see that? Actually, Gerald, yes, who you want to lick? Okay. Actually, the graph itself can give me the answer already because y is equals to this is equals to 0. So, if I put the left hand side here, this y must also be equals to my y is equals to this. This is equals to 0. So that means my y is equals to, Jasmine, pay attention here first. Y is equals to this. This is equals to 0. So y is equals to 0. Okay? Because of this equals to this equals to this. So actually, I get another relationship. Y must be equals to 0. Okay? So if, okay, this equation is this graph, right? Is this curve. Okay? This is the y equals to negative x squared plus 2x plus 5. If I put it on a graph, every point on this curve will fulfill this relationship. Correct? Then now, when this is the equation I want to solve, then just nice, can you see that this left hand side is exactly my right hand side here? So if I want to solve this equals to 0, that is when this right hand side is equals to 0. So if my y is equals to this is equals to 0, that gives me another relationship. My y must be equals to 0. And when these two relationships happens together, that is the solution. Because that is when my negative x squared plus 2x plus 5 equals to 0. So the solution happens when this or the y is equals to 0. So where is my y equals to 0? Cyrus, when is y equals to 0? Where on this graph is y equals to 0? Here. Where else? Y equals to 0. 3 and 4. In between 3 and 4. Okay? On this whole graph paper, y equals to 0 is everywhere here along the x-axis. Everywhere here is y equals to 0. Because y tells us how high or how low. When y equals to 0, it is the entire line. So actually, this entire line, I use red, can see better. This entire line is the line y equals to 0. So on this graph that I draw, where is y equals to 0? Jasmine pointing, right? Come. Try. Where on my graph that I draw is y equals to 0? Hey, laser pointer lah, point. On my graph and y equals to 0. The graph is the curve that I draw.
3.4.
Y must be equals to 0 and it must be on the line that I draw.
3.4.
What 3.4? The number is correct, but how, Jasmine? Can? Okay, good try. Correct. More exact. Aq. More exact. Where? Where on my graph is y equals to 0?
Where your graph is
Point lah. Point where on my graph? Here. Correct. That is 1 point. One more. Okay, perfect. Okay, very good. You all see where Aq point? This is my graph, the curve. Then this is y equals to 0, So this is the point on my graph where y equals to 0. This is also the point on my graph where y equals to 0. Just now Jasmine said between 3 and 4. So she know, but then she never really point there. Correct, Jasmine? This is where you want to point? Yeah. So from there, that are the two solutions for my equation already. Okay? So the equation was asking me to solve, and when I want to solve, I want to know what is the unknown. I want to know what is x. So when I read from my graph, my x value is this point where my graph intersect or cuts the x-axis. Which is why just now I straight away tell you the solution is actually negative 1.4. Because this point here is negative 1.4. X equals to negative 1.4. Which is also why just now I tell you the other solution is here. This exact point, which is positive 3.4. Just now that one is negative 1.4. This one is 3.4. Okay? Can? So that is the solution already. Can? We look at one more, then later you all will try. So this time round, draw the line y equals to 2. Try. Draw on this graph. You draw already. Draw y equals to 2. Okay, Gerald draw already. Try, everyone. Where is y equals to 2? There. My screen not even on the grid. You point. You know where? You know where you go and draw.
You're right.
Yes, correct. Cyrus is right. Where is y equals to 2? Y tells you the up and down. No. Y equals to 2. Yes. Then how do I draw the line y equals to 2? Yes, correct. Then go and draw. Wow, Alexis. I am surprised you really know. Okay. Y is up and down. So y equals to 2 is here, right? Here is also y equals to 2. Here is also y equals to 2. Because all these points are 2 high above the x-axis. So if I join all these points together, that will be my y equals to 2. Okay? Correct, Correct. Very good. Very good. Very good. Very good. Where? Where is y equals to 2? Yes, why you keep calling my name? That is correct also. But your line, later I draw, then you all see what is the difference between yours and mine?
Yes, ma'am. Where's my wallet?
Did you draw?
I draw. And I help you write.
No, they want you to draw the line y equals to 2.
But it's correct, right?
No, you never draw the line y equals to 2. That's why it is not correct. Yes, if you draw like that, it's correct. Okay. I see most of you are able to draw. So now I show you. Hello, hello. When I'm drawing a line, I want to draw the entire line. Some of you just draw in between the points. That is not what we want. We want the entire line, so I must draw along the entire horizontal line. Okay? I must draw this entire... Extend the entire line. Okay? Extend the entire line. Then, hello. Then go and label it. Whenever we draw a line, we go and label. Okay? So after I draw this horizontal line, I label it as y equals to 2. Okay? Luis, this is how we draw the entire line. Don't just draw in between. Extend, then label. Okay? Okay. This time round, if this is the equation that I want to solve, then I compare it to the graph, the equation of my graph. The right hand side is this left hand side. Okay? So, remember the equations of the graph that I have is y equals to negative x squared plus 2x plus 5. Now, if they say that this right hand side is equals to 2, that is to say that y equals to 2. And the solution of this equation will occur when on my graph y equals to 2. So, I like to give my laser pointer to people to point.
I want to try.
So, this time, where is the solution to this equation? Where is the solution to this equation? Because now, my right hand side is 2. So my y equals to 2 now. Then on my graph, where is y equals to 2? Wrong. No, not the whole line. Where on my graph is y equals to 2? I want to know the x. Okay. Very good, Lexus got it also, So the two solutions are here and here. Then the answer that I want to give, they are asking me for the solution of this equation. The unknown is x, so they are asking for my x value. So I must go to my graph, then go and read. One of the solution is x equals to negative 1. The other solution is x equals to 3. So that are the two solution to my quadratic equation. X equals to negative 1, x equals to 3. These are the two solutions. Okay? Follow? Okay.